Dear students, in this session we are going to discuss some simple definitions on what is a linear PDE and what is a semi-linear partial differential equation, what is a quasi-linear partial differential equation, and what is a non-linear partial differential equation. So this is going to discuss these definitions and this is going to be a different types of solutions for a linear. Complete integral or complete solution, singular integral or singular solution, or general integral or general solution. Three kinds of solutions may arise for a single differential equation, and we are going to classify different types of partial differential equations as standard type 1, standard type 2, standard type 3, and standard type 4. And for each of the types, we are going to discuss the method to solve the partial differential equation. Solve in the sense we are going to obtain the solution, that is the z, which is a function of x and y. So this is what we are going to do in this session. First, already we discussed what's a partial differential equation. Now, what is a linear partial differential equation? Linear partial differential equation. What is a linear partial differential equation? There are various definitions available, and a partial differential equation is called, the partial differential equation is called linear, linear PDE if it is linear in the unknown, linear in the unknown and its derivative, linear in unknown and its derivative, linear in its unknown and its derivative, For example, consider the function, say u, which is a function of two variables, x and y. U, which is a function of two variables, say x and y, where x and y are independent variables, and y. A second order linear PDE, linear partial differential equation is of the form like this. A1 is a function of x and y. A1 of xy into u xx. So what is u xx? Actually, this is a dou square u by dou x square. This is we write it in like u xx. That is already discussed already. U xx plus another a2 of, that is also a function of x and y, and u xy. What is u xy? Dou square u by dou x dou y plus a3 of x comma y u yx plus a4 of x comma y with respect u yy plus a5 of x comma y a suffix of ux plus a6 of x comma y uy plus a7 of x comma y u, and this is equals to f of x comma. This is a second order linear partial differential equation of the unknown function. The unknown function is u, and this is how a general second order linear PDE looks like. See the unknown function u and its derivative, you can see that is uxy, uyx, everything, they are called as the derivatives of the unknown functions. All are in linear. The power of the highest power of the variables is 1. What is the variable here? U and its derivative. So that's why we classify this differential equation, a partial differential equation, as a linear. And why it is called second order? See, the highest order is 2. So this is a general linear second order PDE of the unknown function u, where this ai's and the function f, the right hand side function f, are functions of the independent variable only, of the independent variable only. And what happens if the ai's are constant? If the coefficients, which we call it as coefficients, if ai's are constant, then what is the name of the differential equation? Then the differential equation here, then it is called linear partial differential equation. Second order linear partial differential equation, we use the word with constant coefficients, with constant coefficients. If these ai's are depending on x and y, the independent variables, then we call it as linear partial differential equations with variable coefficients. That if the ai's are constant, we call it as constant coefficient, but both of them are, we call it, classified as a second order linear PDE. If what happens if the right hand side function is 0 at all points of x and y, that is the next definition we are going to see. If this right hand side function of the above equation is 0 everywhere, all points of x and y, then the partial differential equation is homogeneous. Otherwise it is called non-homogeneous. Otherwise it is called as non-homogeneous second order linear PDE. If the right hand side f is 0 everywhere, we call it as a homogeneous PDE. If it is non-zero, we call it as non-homogeneous second order linear partial differential equation. Now we go to the next kind of differential equation. It's called semi-linear. What is called as a semi-linear partial differential equation? How it varies from a linear partial differential equation? Just a slight variation. The highest order derivatives, appear only, the highest order derivatives appear only as linear terms. With the coefficients that are functions of independent variables only. That are functions of independent variables only. functions of independent variables only. The lower order derivatives and the unknowns, the lower order derivatives and the unknowns unknown functions, lower order derivatives and the unknown functions may appear arbitrarily, otherwise. Okay, this is how a semi-linear PDE. See the highest order derivatives. For example, if we go to this linear partial differential equation, what are the highest order derivatives? Second order. This uxx, uyy. Only these terms will be linear. We cannot guarantee that ux, uy, u, they may be non-linear. That is, there may be product of ux and uy, or they may be they will have the non-linear terms. Only the highest order derivatives, those terms only will be linear. And this, suppose a5 onwards, suppose we multiply the ux with the u or uy, ux uy, or here uy into u, so then we get non-linear terms. So if that is a case of a differential equation where highest order derivatives are linear and these coefficients a1 are compulsorily functions of x and y alone, and we cannot guarantee the lesser order terms, that is ux, uy, u, etc. They may be linear or non-linear. Then we say that differential equation is semi-linear. That is why we know the highest order derivatives appear only as linear terms with coefficients that are functions of independent variables only. The lower order derivatives, that is ux, uy, u, and the unknown functions may appear arbitrarily otherwise. What is the meaning? They may be linear and sometimes may be non-linear. Okay, then that is the case, then we say that differential equation is semi-linear PDE. Now, for example, same like this, we are going to generalize the equation. For example, a general second order semi-linear PDE, a semi-linear partial differential equation in two variables. In two variables is same like linear, a2 of x comma y into u y plus a3 of x comma y into u yx plus a4 of x comma y into u y. So these are the highest order terms. Those terms must be linear, and the remaining lesser order, that is ux, uy, u and other functions, everything we group together, and they may be linear or they may be product of u, ux, u, uy, or ux, uy, something like this. So we put like this, a function of ux, uy, u, x comma y. The right hand side function also is included in this, and we equate it to 0. So everything I will include here. This may be a non-linear term. So guaranteed that the higher order derivatives of these unknown functions are linear, and this term may contain non-linear terms of the unknown function and its derivative. So that is the case, we say this linear differential equation is called as semi-linear PDE. And now what is called quasi-linear PDE? What is a quasi-linear partial differential equation? What is the definition? That is the extension of this semi-linear. quasi-linear PDE. Here the highest order PDE likewise appear only as linear terms. Likewise appear only as linear terms, but the coefficients, that a1, a2, everything, the coefficients possibly functions of the unknown and its derivative, functions of the unknown and its derivatives. So I will give just generalize this. See, it will be like this. A1, usually it is a function of x and y only, but here it is a function of now u, maybe ux and uy. It will be like this. A3 of x, y, u, ux, uy, uxy plus a4 into x, y, u, ux, uy into u, yx. And then finally the function of ux, uy, ux and y. If the partial differential equation is of this type, we call it as, it is a quasi-linear partial differential equation. This highest order derivatives appear in linear terms, but the coefficients, they depend on the unknown function and its derivatives, lower order derivatives, that is ux and uy. If this is the case, then we say that PDE is a quasi-linear PDE. Now, what is a non-linear PDE? A partial differential equation that is not linear, we call it as a non-linear PDE. The simplest way we can explain this: it contains non-linear terms. It contains non-linear terms, and it involves higher powers of PQ and PQ. It involves higher powers of this P, Q and PQ, like this. These terms will be of higher powers, P square, Q square, PQ square, or something like this. So these kind of terms are there in a differential equation. We call it as a non-linear partial differential equations. Note, just a very important point to be noted. Linear PDEs, these linear PDEs are obtained. Linear PDEs are obtained by eliminating arbitrary constants and arbitrary functions. Arbitrary constants and arbitrary Now a linear PDE, a linear PDEs are obtained by eliminating arbitrary constants as well as arbitrary functions. Now these are the basics of basic definitions of what is a linear PDE, semi-linear PDE, quasi-linear PDE, and what is a non-linear PDE. And now we are going to discuss what are the different kinds of solutions as a PDE may get. So not always the same solution will be there for a same single PDE. There are different types of solutions you will be getting. And what is a solution of a partial differential equations? A solution, or they use the word integral, both are same. A solution or integral of a partial differential equation is a relation between the dependent and the independent variables that satisfies the differential equations. So this is a simple definition of what is a solution or an integral of a differential equation. It will be noted that two types of solutions may occur as a solution of the same equations. So we are going to discuss what are the different solutions of a PDE. The partial differential equation which involve higher powers of PQ and PQ are called as nonlinear PDEs. And now we are going to discuss what are the different kinds of integrals or a solution of a partial differential equation. Before that, I will just write what is a solution of a PDE. Solution, or they use the word integral. Solution or integral of a partial differential equation. Now, a solution or integral solution or integral of a partial differential equation is a relation between the dependent variable with the dependent and the independent variables that satisfies the differential equations. That satisfies the differential equations. So this is and there may be many solutions they occur for a single differential equations. We are going to classify what are the types of solutions PDE may get. So the main three different side of solutions we are going to discuss. The first one is, we call it as a complete integral or a complete solution. Complete integral. The second one we call it as a singular integral. The third one we call it as a general integral. We can use the word solution for in place of integral also. Complete solution, singular solution, and general solutions. Now we are going to discuss what are they and how to obtain these kind of solutions. We are going to see.